Welcome, everybody. My name is David Heffelfinger. I'm here with Cesar Hernandez, Jonathan Gallimore from Tomitribe, and we're going to be talking about some recent Tomcat CVEs, common vulnerabilities and exposures. I'll be moderating. Cesar and Jonathan will be providing information about the CVE. Why don't you guys go ahead and introduce yourself, please?
Yeah, sure thing. So I'm John Gallimore. I head up the support team here at Tomitribe, and I've been doing that for a very long time now. I've been with the company for about 12 years. And I've really come into open source probably about 20 years ago now as an Apache Tommy contributor. And I do have a particular interest in looking at CVEs, both in terms of trying to understand what's going on and what the risks are around particular vulnerabilities, but also to try and understand them in order to be a better software developer as well. So I do have a kind of a keen interest in this area, and I like to try and explain these things and help our customers out.
Very good. Cesar?
Okay, yeah. So my name is Cesar Hernandez. I am a senior software engineer for Tomitribe. I have been in the Java ecosystem for plus 15 years now. I am also an Apache committer for many open source projects, including Tommy and many others.
We're going to discuss CVE 2026-24734, which is Apache Tomcat native, Apache Tomcat OCSP revocation bypass. We'll also cover CVE 2026-24733, Apache Tomcat security constraint bypass with HTTP 0.9. And the last CVE we're going to cover is 2025-66614, Apache Tomcat client certificate verification bypass due to virtual host mapping. All right, so we're going to cover those three. Let's go ahead and get started with CVE 2026-24734. And the first question is, the CVE makes reference to improper input validation vulnerability in Apache Tomcat native. So what is Apache Tomcat native? The Tomcat that I download from the official Tomcat website?
You're right, David. So we need to separate first. When you download Apache Tomcat from the official website, the zip file, for example, what you get is the Tomcat server itself, right? So yes, it's written in Java and is able to run on top of the JVM without any native component at all. That being said, Tomcat native is different. It's an optional add-on. You can think as an add-on, not the full runtime that you download by default. In the case of the Tomcat native, it provides a native integration layer so Tomcat can use the OpenSSL that you already have for TLS instead of relying on the standard JSSE, which is, we all know, the Java standard for SSL and TLS implementation. So the practical distinction, you can think of this like the standard Tomcat is just a server, while Tomcat native is an optional native extension for TLS path. In newer Tomcat versions, there is also an FFmpeg-based implementation for OpenSSL path that uses Java foreign functions and memory API instead of JNI. But this is still an OpenSSL path, so not the default JSSE path that you may have if you download and install your Tomcat server.
Okay, very good. Couple of things from what you're saying. Sounds like if I'm running Tomcat native, I will know about it, right? It's not something that accidentally will happen, right?
Yeah, that's correct. So for this CVE, the important question is not, did I download Tomcat from the official website? But actually, the real question is, am I using the OpenSSL-based OCSP path? That's like the question that you need to make at yourself. And if you're using the default JSSE path, then this issue doesn't apply to your install.
It's probably just worth chatting a little bit about what's actually going on with this CVE, I think. The descriptions that you get on the CVE, they typically tend to be something that hopefully gives you just enough information to pick up on whether you may be vulnerable to this, but it doesn't give you a lot of in-depth information or potential ways to check you're exploited, because obviously that puts information into the hands of bad actors. But basically, if you're not familiar with these mechanisms, one of the things you can do with Tomcat is you can configure it to require the requester to provide a client certificate with their request in order to basically check that they're allowed to access that resource. So it's not just a case of the servers sending a certificate to say, hey, I'm this server, it's trusted and this is a valid address. We're checking who the client is. And in particular, this particular CVE focuses on the revocation of those client certificates. I may be providing access to a person or a machine, and then I would then want to revoke that certificate that they're using. And crucially, there's an issue when using something called OCS. And this is basically what you'll find is in the certificate, there's a URL that says, here is where you can go and check that this certificate is still valid. And that URL is what we call an OCSP. And so basically what happens is Tomcat will go off and check with the responder to make sure that certificate is still valid. Those checks were basically incomplete. So there are scenarios whereby you could present a certificate that's been revoked, but actually still be allowed access to the resource. So there's some important things there. You will be potentially exposed to this issue if you're using client certificates. So that may not apply to you if you're just serving a Tomcat application on the web and people are, say, logging in with a username and password, for example. Okay.
Okay. Very good. So Cesar mentioned FFM, Foreign Functional Memory API, which is a replacement for JNI, the Java native interface to interact with native code that's been around forever, decades, I would think. FFM is pretty new. It was introduced in Java 22. So if I'm running Tomcat in a version previous to 22, Java 17, for example, am I still affected by the CVE?
The answer is on Java 17, the FFM path is not available, right? But you can still be affected if Tomcat native is installed on your environment. And remember that if this is the case, you're using Tomcat native and Tomcat is using OpenSSL with OCSP enabled, then you are in the path and in the scope of this CVE. So the real question is not just the JDK version, the version you're using, the Java version you're using, but the real question is whether you are using OpenSSL and OCSP rather than plain JSSE.
So FFM or JNI doesn't matter. What matters is the Tomcat native, correct? I understand that correctly?
That's correct.
All right. Next question, I guess that's answered, but we'll go through it anyway. If I'm using an older version of Java prior to 22, say Java 17, and plan to upgrade to a newer version of Java that supports FFM, like Java 25, for example, what are the considerations to make sure I use FFM or not?
That's an interesting one. Just by moving from Java 17, your current installation, your Tomcat install, just by moving from Java 17 or 11 to 25, does not automatically switch Tomcat to FFM. That only happens if you configure it explicitly. And I think it works for you to check your server.xml file if you are not the one responsible for doing those changes, if there's a different team or you have AI automated in all these configurations in your container environment. So check your server.xml and check which SSL implementation is being selected. And decide intentionally whether you want to use JSSE that you mentioned it has been there for ages, or FFM or a legacy native integration. If that is the case, it will depend on your scenario. But just for switching from Java version from 17 to 25, that doesn't mean you are automatically vulnerable to this CVE.
Okay. And if I'm using a newer version of Java, say 22 or newer, is there any way I can disable FFM so that I can be safe in my Tomcat installs?
Just you can avoid it. We have, for example, the clean way is to pin Tomcat to use JSSE, as I explained, in your configuration, and avoid OpenSSL lifecycle configuration. If you don't need native OpenSSL integration at all, do not enable. And if you do, you use it currently, make sure that you are on a fixed Tomcat release that addresses the CVE. I know that sounds obvious, but it's part of the requirements. If you have that requirement, you have the requirement to have the latest and greatest Tomcat.
Right. More than we care to, a lot of organizations don't upgrade their Tomcat version. So yeah, we need to keep an eye on those kind of things.
That's correct.
All right, thank you. I think that's all the questions I have for this particular CVE. So let's go ahead and move on to the next one. This CVE deals with HTTP 0.9, which was released in 1991. That was 35 years ago. We probably have members in the audience that are younger than that.
Yeah.
So, anyway, is there a configuration mitigation in Tomcat that we could disable the supporting of this old version of HTTP?
Yeah, so potentially, but this is really one where we need to patch to mitigate against this. But it's probably useful if I just actually show this particular CVE. So I'll
go ahead.
I'll just share my screen so that folks can see it. All right, hopefully that's working okay.
Yes.
Yeah, perfect. So basically, I've configured Tomcat so that it has some constraints on doing get and posts on the Tomcat root application, as it were. I can validate that by doing a curl here. So you can see if I try and access this URL here, I get a HTTP status 403 saying this resource is forbidden. I can't do a get against it. If I do a telnet against this, in fact, I'll just do that. If I type in head / you can see that's actually given me. So this is because I haven't put in HTTP 1.1 at the end of my head request. This has been treated as a HTTP 0.9 request. And actually that head verb isn't valid at all. What's happened is that Tomcat's basically done a get against this resource and has actually returned some content that I shouldn't be allowed to see. It should still return a 403 forbidden. I potentially could go and put in head in the blocked verbs as well, but for this particular one, this is really go ahead and patch it. Is potentially just a very simple bug. Really needs a patch to fix.
Did I see you using Telnet to test this, John?
You did. Other alternatives may be available.
Telnet is old. For those that haven't been around for decades, right? Telnet is what we used to use before SSH and OpenSSH. It's insecure. That's why. So not everybody, or almost nobody, has a Telnet server anymore. That's why I bring it up.
So the key thing is I'm not connecting to a Telnet server here. With the Telnet client, you can connect to any. You can connect to any TCP port. Just send text to it. There's various other ways that we could do this for sure. If anybody knows how to do a curl request, feel free to, shoot me an email. But the important thing is hackers don't play by the rules. So they're not necessarily interested in just sticking to making HTTP requests that are valid. Quite happy to make tools there. They'll make Python scripts, etc. That make invalid bad requests to try and trip servers up. So I'm just using Telnet as an example, but basically echoing that text into anything that will send that over to the TCP port will achieve the same thing.
Let me share my screen.
Yeah, sure.
Okay, and next question is, the description of the CVE specifies that older end of life or EOL versions are also affected. How can I determine which versions are end of life as of today?
So great question. Basically, from an open source perspective, there are 3 branches of Tomcat that are currently still supported by the community. They are Tomcat 9, Tomcat 10.1, and Tomcat 11. Okay. So if you're outside of any of those, so if you're using Tomcat 10.0 or 8.5 or 8.0 or 7 or 6 or older, those versions are all end of life. Okay. One of the things that Tomitribe does is we provide patches for end-of-life versions of Tomcat. So if you are running an end-of-life version and you would like to get fixes for these CVEs, please do get in touch. We'll provide some information on how to do that at the end of the session. But yeah, the list of stuff that isn't end-of-life is shorter than the list of stuff that is. Tomcat product has been around for a very long time.
Okay. Yep. So essentially, if you're using a version which is not one of the ones you mentioned, chances are we're using an end-of-life version.
Absolutely.
Yes, and this had been changing too in the past 2-3 months. For some transitive dependencies or for ActiveMQ, Tommy, or Tomcat, sometimes not all the transitive dependencies projects check how the end-of-life versions are affected or not. So in the case of Tomcat, depending on the CV you're seeing, you may see or not if end-of-life are affected or not, as Jonathan mentioned. So this is important to check out.
Okay, very good. I have one more question regarding the CVE. It's pretty common to put Tomcat behind a reverse proxy. A popular option is the Apache web server with mod.jk, for example. So if I have Tomcat behind a reverse proxy, am I still vulnerable to this? And on that note, what if I'm using a container? Am I vulnerable to the CVE as well?
So I think these are great questions. There's no definitive answer. I did a test with this specific CVE. I ran Tomcat and I put Apache HTTPD in front of it as a reverse proxy, and I just used mod proxy HTTP. Sent the request through to HTTPD, and HTTPD itself replied with a HTTP 400 response. And that request will not have made it through to Tomcat. I haven't tested other reverse proxies. They may behave differently. Similarly, if you're simply running in a container and your traffic is coming straight in on the TCP port that you've mapped through to the host, that's not going to make any difference. If you've got something that's maybe filtering that traffic, that might respond to block that request. But really, you've got no guarantees. So your best bet is upgrade and check.
Yeah, and HTTP 400 that you mentioned, that's an error, right? So I missed the request didn't go through.
Yeah, exactly. It's saying that's an invalid request.
Yeah. Okay, so that's all I have for this particular CVE. So let's go ahead and move on to the next one. The first question for this one is, the description includes end-of-life information for specific versions, 8.5 through 8.5.0 through 8.5.100. But other CVE descriptions don't mention specific versions. So why is this one different from what we usually see?
There have been some changes in terms of how these version numbers get reported with respect to end-of-life versions. This is something that's changed a little bit last year. You can't necessarily depend on these being reported in every case for every CVE. The only thing that we can guarantee is that the currently supported open source versions, you will see a version range for what's affected by those on the CVE. But yes, in some cases with some of the CVEs, they do report whether some of the end-of-life versions, particularly on the 8.5 branch, are affected. And it does, I think it depends a little bit in terms of the timing of the CVEs as well. So some of the CVEs that we see here, they will have been reported for a responsible disclosure process at Apache quite a long time before they get fixes are released, and then the CVEs are typically then made public sometime after those releases have been made available, so people have the opportunity to upgrade before it becomes public. And there's a few factors there.
And there is also slightly 50% related with the question, so I wouldn't go deeper. But a couple days ago, less than 1 week, NIST announced that the NBD, which is the catalog for CVEs, is adopting a new model due to the spike of the 263 surge in CVE submissions. NBD now will prioritize enriching CVEs found in software used by the US federal government. So this is changing a little bit the rules of the game. It's aligned with the questions you made, David, because you now, depending where you are, depending the type of software you're running and the region in the world you are, you may be interested in getting more than just what US federal government use. So in that case, is that correlation that we have been mentioning in this call.
Okay, very good. I have one last question for this CVE. It mentions TLS, Transfer Layer Security. So how can I validate if my TLS configuration is affected by the CVE?
Probably the best answer I can give to this is to actually show how this particular vulnerability actually works. I've shown the config for different virtual hosts, so you can see what you're looking for in your config. When you are looking at, when you actually make a request to a server, takes a look, your DNS will resolve to an IP. You'll connect to that server's SSL port. And then typically we pick which virtual host we're going to route the request through to with looking at the host header. Okay. There's also something called an SNI header, server name header, at the SSL layer. Okay. So, where this particular vulnerability creeps in is where the host header is different. The host header on the HTTP request is different to the server name header at the SSL layer. Okay.
Thank you. So that's all the questions I have, but feel free to reach out to Tomitribe. Tomitribe offers support for Tomcat and Apache Tommy as well. So you guys don't have to be watching for the CVEs all the time. You have someone else watching over for you.